Hello, I'm Dr. Lawrence W. Moore, and I'm here to show you the newly released update to LWM Rack, the first update. This is 1.01 beta. This update adds some new modules, and what I like to do is remind everyone, especially if you're a new viewer, the home site for this development is at lwmmusic.com. Click on the face to get in. And then this development's on the software page under its own name, LWM Rack. And LWM Rack starts with an initial video about the release 1.0 beta. What you're watching now is the 1.01 beta update, and it's an update, upgrade, continuation, continuing to build the modules video. And if this is the first video you've seen, you will want to look at this other one first to see how the system works, and then proceed to this video 1.01 beta to see how the new modules work, because here's the original system that you can download, an example that I make in the video, but it shows you how the system works. And when the downloads are up for this one, 1.01 beta, the new modules are really all I'm going over in this video, so I kind of expect that you already know how to use the system. And if you don't, you want to watch this video first. This release will also have 2 downloads with it, where I'm basically giving you the full system again, both as with a blank rack and with an example instrument. The example instrument is what I'm making in this video as a demonstration of the new modules and how they fit into the system. So let me get to that. Okay, so I'm going to move this over. This is this folder here, the LWM Rack 1.01 beta example folder. Both of these will be downloadable, and as I'm recommending, keep a blank one around for when you want to build from scratch. It's easier to build from that where there's nothing that has been saved into it yet. But anyway, I'm going to open the rack file. To save some time, I've already put in some modules, and I've put in the 2 new ones. I'm going to open this, right-clicking on it, going to open, and you would know, if you saw the first video, that although I opened Rack by opening the subpatch within Rack, by right-clicking on it and going to open, I'm now viewing the modules file. And this is the file that you definitely want to save before you close things when you're done making your instrument, because this is what saves your patching. And I've already done a few things, but let me first of all show you the new modules. You see here we have a Midi in module. This was in the original release, and it's hooked up, as we did before, to a tool that I call monophonic. It's for making a smooth monophonic keyboard playing. Eventually there will be a tool for polyphonic when I make polyphonic modules for the system. I'll be able to use the same MIDI input and just have a different thing that handles notes and velocities in a polyphonic way. But for now, this is just going to make things sound smoother for the monophonic instrument that I have built here. That's all from before. These are the 2 new modules, Midi in Extended and Midi Control 8, or Midi in Control 8. And you could see them in the modules folder here. Midi in Extended and Midi in Control 8. And, Extended Control 8. Yes. I read them off in reverse order. And they have their folders here where basically their settings are being saved, because they already have been created and have a name. And all that is part of the system that you saw in the first video. So anyway, in Midi in Extended, what I did is I added a few more MIDI messages that could be received. Now we could receive the controllers for volume, pan, expression, and sustain. So this module receives these signals coming in and sends them out as control signals as far as volume, pan, and expression is concerned. So when they come out, they're in a range of 0 to 1, denoted by their orange color, as opposed to their MIDI range of 0 to 127, which is denoted by the blue color. And so I just have it set up that my controllers, like mod, pitch bend, as well as these, all are within the range 0 to 1 because that's more mathematically useful for the other modules in the system. The sustain is color-coded yellow because sustain comes out as a 0 or 1, not 0 up to 1 as a range, as these are, but it's just 0 or 1. I have not made any input for sustain to be used on any of these modules yet, but I will in the future. And I will probably do it in a way where you will have an external tool where you can kind of govern how sustain affects things. And then it will go into these in one of two ways, either as a control signal where it would basically go into orange inputs that exist, or it would be a yellow input. I haven't quite decided yet how I'm going to manage it, but I might do a little bit of both so you have both options, because different instruments you may want to have sound different, whether the sustain is held or not. You wouldn't want sustain on some instruments to just hold a steady note for you. You would just want it to decay slower. And in some sounds you might want it to just hold the sustain level of the note. So I will basically be putting that in later, but right now we have a mechanism that receives this information. But you could go ahead and use your expression pedal as well as volume and pan signals right away and hook them up. A very appropriate thing would be to hook up volume to the overall level of the output over here on the audio out module, and to hook up pan to that. If you were using this as an external instrument with a DAW, where you had like a virtual MIDI loop or a virtual MIDI port connected from your DAW to this to PD, then you would be able to use volume and pan sliders on your DAW to control the volume and pan of this instrument. And this is a perfect way to hook those up. Next we have a MIDI controller in where it gives you 8 controllers that you can define by typing numbers into the orange boxes here. By default they're 21 through 28. But you could change them to whatever MIDI controllers you want to. It is advised, though, that you don't change them to one that's already being used, like volume and pan, which is MIDI controllers 7 and 10 respectively. I use 21 through 28 as a default because those are undefined MIDI controller numbers. And I believe 31 through 38, 41 through 48, 51 through 58 are all the same as well. And literally you could have 2 MIDI control 8 modules in here, 3, 4, however many you want, all with different names, of course. And as long as they have different names, they could exist simultaneously and not get parameters confused. And then that way you could use more than one of them to have like 16, 24, 32 controllers. It's up to you, because there's a lot of undefined MIDI controller numbers in the specification that you can use for knobs and sliders that you have on a controller keyboard. So this module will save what your controller numbers are with the patch. As you know from video 1, basically all these modules are saving once per second. And so these get saved once every second. So when you change them a second later, it's saved that way. It does not save their values though, because this is something that's more performance oriented. On the fly, you use the knobs to control parameters throughout the other instruments here. The color-coded blue here, just to make a differentiation between them and the controller number. This is the actual controller number, and this is its value. But they do come out as ranges of 0 to 1. And that's why A, B, C, D, E, F, G, H are all color-coded orange down here below. And so you could, for example, use this, what I'm calling Midi Controller A, which is 21. Could use that to control, for example, the mix between oscillator A and oscillator B, and so forth. As more modules are created, you'll have more things that can be controlled, or more things that you may want to control with physical knobs and sliders on your controller. So this gives you a way of expanding what MIDI comes in. And you can do it module by module. If you only have a keyboard that has like 8 knobs on it for controllers, use one. And if you have others, if you have keyboards with other knobs and sliders on it, then you can definitely add more. And then you can name them A, B, C, D, or whatever, so that way they have different parameters. And they would save to different text files in their save folders here. This is saving to 8 CTL in, because that's what I named it. Okay, so those are the 2 new modules. There's been one update to, there's been 2 updates to existing modules. Actually, when you look at the README file, if you're interested in seeing all the specific updates, there's a couple things that have been done, but basically in this Midi In module, I simplified some of the mechanisms on the inside, but it won't affect anything that you see as a user. That'll be something I'll talk about in the Learning Synthesis with Pure Data series when I do the Series 2 Lesson 6 video that will cover the making of these modules, as well as the other updates and how they were done. Another update over here for the audio out is something that you can utilize and will be obvious to you. You can now record to file with the audio out. You can record straight to file, so whatever level things are coming out, when you set this level indicator here or pan here, it records it as is, as you hear it. And so it records it straight to file. It'll record it into this folder, and it'll name the file the name of the module. Right now it's called main out, and so it'll call it main out.wave here, and it'll be right next to main out text, which is the parameters to the main out module that are being saved. So now you can record what you're playing with your synthesizer. If you want to record more than one thing, then as you record things, you would rename the files or copy them out and rename them as you record them, because otherwise it'll just keep overwriting the same file, because it records specifically defined to mainout.wave or whatever file name, whatever module name you give the module, which appears here. Okay, so what's next? Let's finish making this example. First, I do want to make sure I have MIDI running, so I'm going up to the Media menu, MIDI settings, and input SO Mark II. There we go. So now I do see numbers changing here for note and velocity as I move the keys. And as I move this one knob I have here, yes, Midi Controller 21 is what it's sending on, and I see it changing. So that means, well, I think I hooked up wrong. That's what I did. Because I should have seen this changing over here. Yes, A is the first outlet right here. So hook that up to the M for mix. Now then, you have to be a little bit careful with your inlets and outlets and what they're going to. So now, you see this fader's moving up and down as I move the knob. So I can change the mix. So let me just make some simple instrument. This is going to require me to patch things and then set some parameters. I'm going to use, let's say, a square wave. That'll be the first item to be mixed. And then the second oscillator, I'm going to use a triangle wave. And that's going to go into 2. And here this mixes between 1 and 2 as I move it up and down. So also I'm going to make the square wave down an octave. Ooh, that's down 2 octaves. That's probably a little too much. 1 octave. There we go. Need to hit enter for it to take. There we go. And it didn't. Probably because I waited too long. There we go. Actually, -1. Excuse me. There we go. Semitone. I won't change any of the semis or chorus. I do describe all these features of the main modules in the other video. What else? Let me take this merged. I made a number box for some reason. Let me take this merged signal now, this mixed signal, and bring it into the envelope. Velocity is already hooked up. Let me make sure it's in the right inlet there. Yes, it is. So velocity is coming in. Oh, also, incidentally, I did make the default modules background canvas a little bit taller. So now there's a border around the outside. The size is 620 width by 320 tall for the red outline of this rectangle here, which is the size of the window that allows these things to show through on the rack here, where the cables get hidden and it's easier to adjust parameters. And you see it makes the border on the top and the bottom then looks a little bit nicer. If you need more modules that you're going to fit in horizontally, you can make it basically wider pixel wise. All these modules at this point are 75 pixels wide by 300 tall. So actually it's 620 by 320. I said 300 before, but it's really 320. Giving us 10 pixels of a border above and below and to either side of the modules here. But if I wanted to add one more, I would extend it out this way, for example. Or if you're putting a bunch of modules together in something more complex, you would maybe make it 620 tall, so you have room to put modules in a second row down here. And all that would be done in here on the canvas graphing properties, where you basically right-click on space in this patch, go to properties. You could change your canvas size here, the X and Y axis, and keep it graphing on parent and keep it hiding the patch name. And that's how you can change the size to accommodate more or less modules. Alright, so what else? I hooked everything up to the ADSR, and then I do need to, hook this up to the main out. So it comes out both the left and right side. I'm going to hook it up to both. With more complex design, you can make something inherently a stereo instrument. And as time goes on, I'll be making more and more example instruments as new things get released. But at this point, we should be able to hear something. There we go. And I can move this knob on my controller keyboard, change the mix. That's more of a triangle. And that should be adding a little more square to it because it's down an octave. So let's say you're making a bass sound. You can judge how much of it sounds down an octave and so forth. Hold on just a second. Something sounds a little bit out of whack. Now we just have square. And I'm going to move this manually here. Right. So the down one was a triangle. I thought it sounded like it had fewer partials. And a triangle wave, well, weaker partials. Not fewer, but weaker than the square wave. Now I'm still going to come out triangle here. So this, even though the sawtooth is down the octave, and this one is still at octave 0, it's not being transposed. It sounds brighter because it has stronger harmonics. Okay, so that's a good mix there. And of course I can change my attack, decay, sustain stuff. The sustain level, let's make it a little weaker, so now the attack sounds more pronounced. If I want it to release slower, after I release the key, it takes longer for it to decay. There we go. And if you wanted to change these overall, as you see in the first video, your index value here is basically what the time elements of your envelope get multiplied by. The attack, decay, and release get multiplied by this value here, 2000. So each of these has a minimum of 20 milliseconds, which is barely perceptible, and 2000 as a maximum, which is 2 seconds. And so that's a good setting to have, I think, for your envelope settings. But if you want something longer, you can raise the number. It does not go below 2000, though, because if you did, you would have something less than 20 milliseconds as your minimum here, and if you set it to that, you would hear artifacts or snapping in your envelope. And I try to eliminate that. So I set a minimum of 2000 here. Okay. So in any case, I think that describes the new stuff, except for a few things. Oh, that's right. The tools. There's a couple of new tools. For example, if we go into the tools folder, before we did have the monophonic tool here, which I'm plugged into, that makes the monophonic much smoother. Playing one note at a time sounds smoother as you go from note to note. It goes to the one to another more smoothly. And then when you release a note after already selecting the next note, it doesn't turn that note off, so it makes it much easier to play. And then here I have two inverters, like if you want to invert a control signal or a MIDI signal. Now, for example, if we wanted to take a control signal and invert it, we would type Tools, Invert, C. For example, this says C and I, meaning controller, invert, but it's all orange, meaning it's all control signal. If I wanted to take this controller I have coming into the mixer here, for example, as it is right now, when I turn the knob up, here, let me bring it up on screen so I can do that. As I turn the knob up, it goes up, and it's going to square, and then as I turn it down, it goes down. I mean, that's pretty logical, but let's say you want it to be inverted, or you wanted to invert something else. You can invert it, for example. You can take your controller here, which is A. Make sure I get A this time. Sometimes to be safe, you just pull it out a bit. Go all the way in the corner. There we go. And let's invert it to be the opposite. Now, as you go closer to 1, you're really going closer to 0 as a result. And when you go down towards 0, you're going closer to 1. Basically, a 0.7 would invert to a 0.3 and vice versa. And all the other numbers between 0 and 1 would invert to one another. And so now, I didn't get this one back in the view. So it hit it. There we go. Now, when I turn the knob for the mix, it's going the opposite direction than it was before. Now to you it doesn't make a big difference because you don't even see me messing with the knob, but it's going the opposite direction. So it's just like sometimes if you want things to be changed or just to work differently. Maybe, for example, another application for it would be, we also have another one. Actually, I'm going to use this instead. I have another one here that is a MIDI inverter. So let's say, for example, invert M. Let's say you wanted to hook, not to the combiner, to the envelope here. Take this envelope, for example, where velocity is coming in. Oh, this didn't make because I didn't type tools / invert M. Okay, so now, by inverting our velocity and putting it in here, the peak level of the sound will be louder when you hit the key more slowly, and when you hit it more quickly, it'll be softer. I'm going to hit it quick. Okay. As a result, I'm also not getting a 0 when I release the key. It goes to 127. I didn't get it into the right one. There we go. Turn that off. So obviously that's probably not a one that you want to use, but because it doesn't turn notes off. But maybe you do, depending on what you're trying to play. Maybe you do. But it gives you an option to invert MIDI numbers as well as controller numbers. And we also have a converter here that goes from MIDI to control and from control to MIDI. So it changes the range of 0 to 127 to 0 to 1. And it also changes the number range of 0 to 1 back to 0 to 127. So you can convert either way with those types of numbers. One possible application for this, I mean, a lot of this is for the future, for all sorts of things you might want to try in the future as there's more modules. But right now, one thing that could happen, let's say, for example, we convert velocity, convert MIDI to controller. I gotta type tools / in the beginning because it's in the tools folder. Must have a typo in here. Let's just type it again. Convert M to C. What's going on? Convert M to C. Typo in this file name. There we go. Might as well fix this while I'm at it too. Huh. I didn't notice that before. Okay, so I'm glad I did that. Okay, good. Well, those are the two new ones anyway. So now I just need to type it again. It'll work. Convert M to C. That's why I call them beta. Oh, for crying out loud. Convert M to C. That's what I want to do. I'm just going to copy and paste the name in. Yeah, it must be doing typos or something. This is spelled right, right? C-O-N-V-E-R-T-M-T-O-C. Okay. Must have had a typo when I was typing it in to the object. So, one thing is, like velocity is a range of 0 to 127. We could convert it to a range of 0 to 1 here. And then, let's say, for example, invert C. Got to type tools / first. There we go. So now this controller here gets inverted. And this will work well for the attack time on here. For example, if your velocity is higher number, that means you're hitting the key quicker. And usually then you want the attack time to be quicker too. So when it converts a 0 to 127 to 0 to 1, the higher numbers are going to be closer to 1. So if you invert that, you're telling your attack time to get lower. It's already pulled it down. Now let me hit it slower. There we go. And quicker. somewhere in the middle there at the end. So there we go. You can decide if something like that gives you more of the sound that you want. In responsiveness of the keyboard. So that would be a practical use of those types of converters and inverters. And I'll be making more math objects too that will help you to like convert some things, maybe like change the index value based on something, or all sorts of other changes that would occur. But for now, it's a pretty good sounding instrument, and I've introduced you to all the new goodies, so we're basically done. What I plan to add next, well, I already made them. There are 3 LFOs, one for frequency modulation, one for amplitude modulation, and one for pulse width modulation. So that video, after I make it, will be out, and those downloads will be out. And then I've already made a filter as well, so I need to make the video for that, and then a filter will be added to the mix. After that, you've got a lot of the basics down already. And then from there, there's some future ones I want to make, like a delay. That one I've kind of made, but I didn't test yet. And then I also have a sample player and a sample granulator that I want to make as modules. And so there will be more production in the future, coming up in the near future. So for now, enjoy this, have some fun, and I'll see you soon.